Okay, thank you. Good morning, everyone. Welcome to the Transforming Manufacturing Together Worker-Centric 4.0 Solutions, a digital tech talk hosted by Digital Factory Alliance. Please note this meeting is being recorded, so please make sure to unmute yourselves. I'm Ines Arias. I'm a European project manager at Funding Box, and I'll be your moderator for today's engaging session. We have an exciting agenda ahead, exploring the latest developments in the digital transformation of manufacturing driven by European initiatives. Our agenda features three remarkable projects: OPTIMAI, I4Q, and PeneloPe, all of them part of the 4CDM cluster and funded by the European Union's Horizon 2020 program. These projects focus on worker centric, zero defect manufacturing solutions. OPTIMAI, our first project, is led by Nikos Dimitriou, that aims to redefine the trade off between resources, production time, quality, and performance using technologies such as artificial intelligence and digital twins. Our next speaker is going to be Penelope, that is going to be presented by the engineer Soy Arcaule, addressing large power manufacturing with a closed loop digital pipeline, linking product centric data management and production planning. And our last project today in the agenda is I4Q, represented today by Georgia Apostolou and Miguel Angel Mateo. This project ensures the reliability of industrial data services through a suite of 22 solutions, embracing a zero defect manufacturing approach. These projects not only optimize processes, but prioritize the workforce, driving us towards Industry 4.0. So, without further ado, let's embark on this journey of innovation and collaboration. I'm thrilled to introduce our first speaker, Dr. Nikos Dimitriou, the OPTIMAI coordinator. So, Dr. Dimitriou, the virtual stage is yours.
Thank you, Ines. Thank you for your kind words and for the nice introduction. So, give me a second to share my screen.
Yes.
Okay.
Yes,
Okay.
we can see your presentation. It's in presenters mode.
Okay.
So, mhm.
Let me change that. Okay, and now it's better.
Yes, now it's perfect. Thank you.
Okay, great. My presentation is about worker-centric solutions that we're developing in OPTIMAI, and how basically I'm going to give you a very brief overview about how we have implemented zero defect manufacturing in OPTIMAI and how we are using extended reality to make ZDM worker-centric. Okay, so this is an outline of the presentation, so a brief summary of the concept of OPTIMAI, then a discussion, very short discussion about zero defect manufacturing technologies in the project, and then a focus on the worker-centric solutions that we are developing. This is a very rough conceptual overview of OPTIMAI. So basically, there are five independent components, let's say, or main technologies that are developed. The first has to do with instrumentation of the production line, so developing smart sensors. The second is about real-time monitoring from sensorial data and analysis. Then is a part of AI that is responsible for detecting defects, early detection of defects. Then we have virtualization, digital twins, and so on. And finally, we have reconfiguration of the production line, either based on AI results or through the use of augmented reality. What about ZDM technologies in the project? we have, I'm going to give you two examples of zero defect manufacturing technologies for the project, as they have been realized in two of the pilots. The first one is about microelectronics. So here we have developed a system on a with a camera that uses an image, a high resolution image of electronic port to analyze defects on the port. So without going into too much detail, basically what we are doing is that you can see that better in the next slide. Basically what we are doing is that we have this setup that you see here in the upper left part, where you have a camera that takes a picture of a PCB, analyze the PCB to identify regions of interest, and for each region of interest, it finds a defect. Keep in mind that this is a solution, an AI solution that can analyze up to hundreds of regions of interest in under a minute. Previously, you had to do it with a microscope. Okay, so it's a pretty big step in automation for this particular electronic board. So keep that in mind. We'll see how we can. What we can do with eccentricity to make this solution human-centric. The second technology for ZM is about the detection of defects in antenna manufacturers in telecommunication. This is a system that entails both a line scan camera and a 3D vision system, a laser system. It basically identifies defects on these TV antennas. There are various types of defects that might happen, like broken plastics or broken metallic rods. In any case, we are using this type of sensors, analyzing their signal on the edge near the production machine, and identifying any kind of defect there. And here the process happens in real time, so we have a latency of about 3 or 4 to 400 milliseconds to send the actuation signal that something wrong is happening. So both of these solutions are pretty nice developments in terms of ZM, because they automate the inspection process, the defect detection process. But what is added value for the worker? How is the worker involved in this pipeline? So this takes me to the more interesting part of my presentation. So the first one, the first technological component I'd like to discuss is the decision support system of OPTIMAI that we have, where basically the decision support system is pretty much it's a bigger, more generic framework, if you like, that entails many different aspects of the project. In fact, is the central integration point. So all technological components are one way or another linked to the decision support system. And this includes components for administration, defect detection, monitoring, prediction, historical data analysis, configuration events, everything. But the most interesting part, and the one that I would like to discuss today, is how the inspection results are visualized here. So basically, you see from the two examples I previously presented for the electronic ports and the telecom antennas, you see how the results from the AI are visualized here. So this is not just a visualization endpoint, though. In fact, the worker can take a closer look at the detection results here. By taking a closer look, he can even correct the AI in case there are misdetections or there's something erroneously classified as defective. The worker is able to correct this, to revise AI suggestions. And through this revision, we are able to retrain our AI models and in this way improve them in the long term, improve them through human experience. Uh, so that's one way on how we involve the human in the loop here. Implement this active learning pipeline. So AI results or AI models learn from human feedback and evolve and improve over time. Uh, Also keep in mind that this is not something that we did, just for the sake of involving the human in the AI loop. It's based on a very, very basic problem that all industries have. Defective parts are very sparse. Otherwise the industry would go out of business, the factory. Defective events are very, very sparse. So it's not realistic to anticipate to have 2,000, let's say, or 20,000 defective parts to train your AI model and make it very robust before you deploy it. But what you can do with this active learning through the DSS framework, you can collect data as you go, deploy a model that maybe is not that robust at the beginning, deploy it, make it learn through human revision and human feedback, and at the end, after a period of time where you have enough data, let it be autonomous and operate on its own. So that's one part of that's one component, human-centric component that we have developed in the project. Here you can see more details on the actual visual interface, where the human can select different regions in the picture, designate the particular type of defect, whether you have broken rod or the antennas, or whether you have too much glue for the electronic ports. Also, here you can see, in fact, some tests that we did where through this active learning process, the accuracy of the AI model does increase. You can see this increasing trend of accuracy through this human interaction, because the model gets more, it's retrained based on the corrections of the human. So it does make a difference, this active learning pipeline. And as a final note, we have also connected to the DSS a blockchain model, which basically can store this kind of revisions of the human. So we can have a very good track and immutable track of what corrections have been made on the DSS. So to highlight some interesting aspects of the DSS, we have the annotation, the active learning part, defect detection and monitoring, and finally the notifications. The DSS also does provide some recommendations of the human, but we'll see more of that in the following slide. And finally, having the blockchain to have transparent and immutable documenting of everything that happens. Next, another human-centered technology that we are developing for OPTIMAI is based on extended reality, and basically on augmented reality to be more precise, because we have we are working also on VR, but for digital twins. But today I'm going to focus on the augmented reality part. So basically here we have developed a bundle of modules that run in parallel, that run on AR glasses, on wearable AR glasses, that basically analyze the scene that the worker is in front of the worker's eyes. So here we are doing many different computer vision tasks, for instance, segmentation, pose estimation, and gesture recognition. And based on this analysis of what the worker sees, we can help him, provide him some insights. For instance, this is from one of the use cases that we have here, which is for elevator manufacturing. We can analyze the viewpoint of the worker and compare what he sees with a bill of materials and see if he has everything he needs to carry out his tasks. So here is an example where we identify the different parts before he's about to assemble hydraulic lift power unit. Now for pose estimation, we have also some videos here where basically we can identify the pose of different parts. So here for the valve block, you see how we identify the 3D bounding box of it. Here for a PCB, how we can identify, the orientation of the PCB, and for the antennas, the same thing. But okay, I can. It's natural to consider, okay, so you are doing this 3D pose estimation, but how does this help in the shop floor? I'm going to see in a while. Before we go there, another component that we're developing is about gesture recognition, where the application is quite obvious. We use it to send actuation signal based on what the worker wants to do. So different gestures can mean different things for different use cases. So for the thumbs up, maybe in one of these cases, it means to initiate the inspection process. Then with different numbers designate with the fingers, select different menu items, with a fist to stop and return to the home page. But even configuration actions, this could be, we can make this to stop a machine or not. So here, basically, you see how these gestures are recognized. Now, see, gesture is number 1, or now it change to number 2 here. So you see, we can identify gestures very fast with very small latency. And going to see that again, how we apply that in the software. Okay, I'm going to skip this to save some time. But for the gesture part, to give you an example of how it's useful in the shop floor, we can use gestures from the worker to configure pieces of machine in the shop floor. So here is from elevator manufacturing, from one of the use cases we have, where basically the worker has to turn left or right a valve block, the valves on a valve block, so he can calibrate it optimally to control the motion of an elevator. Basically, what we have done here is, previously, the worker had to take an Allen key, plug it in each of the valves, and turn it left and right. What we are doing right now is that we have developed a structure where you can see it here on the bottom right picture, or a top view on the top left picture, where these Allen keys directly plug in the valve block, and they are controlled with gestures from the worker, so he can make his thumb go left or right, and this indicates that he wants to turn the respective valve left or right. So we do the configuration based on the gestures that he does in the air, without he actually having to go key, or even go inside the and have the configuration. Another example. Yes, so this is basically the vocabulary that we are using. I'm going to show you the video because I've already seen this. So numbers here indicate which valve you want to calibrate. Left and right indicates the movement, different movement of the motor. A static fist is to stop the calibration, and the thumbs up means that calibration is complete. So this is the vocabulary that we are using in that use case. Next, what brings me back to the 3D pose estimation that I previously discussed about, and how it can be used for human-centric, for worker-centric solutions. We are using we're going to use that in the pilots of OPTIMAI, so that we can enable real-time inspection. Imagine that you have machines that need to see what's happening inside. So we want to minimize human intervention in difficult to reach areas, and minimize also unneeded stoppages. So what we are want to implement is to use AR glasses, and when the worker turns his head not towards the machine, but the camera, give him a live view what is happening inside. We have simple example.
I think we may. Am I the only one that is experiencing problems with this presentation? Is Nikosh frozen at the moment?
Yes.
Yes.
Yes, I think maybe he's having bad connection.
Yeah. Okay. So please, those that have the camera on, if you can please switch it off during the presentations. Let's see if like that we can improve the connection. Otherwise, let's give Dr. Dimitriou a couple of minutes for to reestablish his connection. Um, Dr. Dimitriou, if you can hear us, could you try to leave the meeting and come back to see if we can reestablish the connection, please? And in the meantime, I ask our audience to please be patient with these technical problems. Thank you.
Nicholas is still online, so I wonder if he's even aware of this issue.
Yeah, I texted him in a private message. I think now he left. Can you confirm that that he left?
I
Can
still
I?
see him.
He's actually connected. He just seems to taking his camera off.
Okay.
I
So
told
let's.
him also.
Thank you.
Yeah. Let's give him a minute. Otherwise, we can jump to the next presentation and come back to his later on.
Well, I got a message from him. He's connecting in about 1 minute.
Okay. Okay. So
So let's be a little bit patient and he will
yes.
reconnect. Thank you.
Thanks,
Thank
George.
you. Well, in the meantime, while we get wait for Dr. Dimitriou, Linda, we mentioned that these three projects, OPTIMAI, I4Q, and Penelope, are members of the 4CDM cluster. Perhaps in our audience is a representative from a project that could also take part in this cluster. If you could, I don't know, tell our audience what the 4CDM cluster is about, and if there are openings for other projects to join. It could be also, I think, a good information for our audiences today.
Yes, of course. Thank you, Ines. So for those of you who are unfamiliar with the ZDM 4ZDM cluster, it's a group of projects, um, Horizon projects that does welcome new projects all the time. So do get in touch, and I'll put the website link to the joint cluster website here in the chat. So do get in touch. Don't hesitate if you are interested and you're not yet part of the cluster. I see Nikos has joined us now, so let's see if his connection works better. Go ahead, Nikos.
Yes, yes. Thank you, Linda, and sorry to everyone for the interruption. I had a problem with my connection, and I don't really know where you lost me. Which part of my presentation you lost me? It was near the end, I guess.
Well, if I may, Nikos, it was about the new feature about the X-ray.
Okay, okay. Okay, so yeah, very short. I'm gonna keep it very short so that we don't mess too much with the schedule. So. Uh, Here, can you see my screen now?
Yes, we can. Thank you.
Okay, sorry again for the interruption. I'm going to just give you an overview of this slide and stop, because I believe that's a very interesting part, and this connects the 3D pose estimation that we're doing with an actual application in the shop floor. So basically, this X-ray module, which is X-ray for X-ray as we're doing in medical examination, but also for extended reality. Basically, what it does, it allows the worker to see behind obstacles. Okay, so imagine that you have a PCB, as we see in the example here, which is occluded. It's behind an obstacle, and by using the view from a camera which is outside our field of view, we can register this view to augmented reality that the worker has on. So, for example, the worker that stands in the picture on the right, that stands behind this white separator, let's say, he can see the actual PCB that stands behind. Okay, and we do that by 3D pose estimation of the PCB and multi-camera registration. Basically, we transform the viewpoint of the camera that sees the actual PCB to the viewpoint of the worker. And why this is important? This is important because it allows visualization behind obstacles. Imagine that the PCB is inside the 3D, inside the electronic circuit printer, and you don't want to open up the lid, but you want to see what's happening inside. We can do it like that. Visualize what's happening inside, and have green for good parts or red for defective parts. So that's it from my side, and sorry again for the delay.
No, that's perfect. Thank you very much, Dr. Dimitriou, for that insightful presentation on OPTIMAI. Please remember that you can already write your questions in the chat box. We will address them in the last part of the webinar with a Q&A session. And now we proceed with the next project presentation today, that is Penelope. Please join me in welcoming the engineer Soy Arcule, a research engineer from the University of Patras, the Department of Mechanical Engineering and Aeronautics. Good morning, Soy.
Hi, good morning. Thank you for introducing me. So, yes, I'm a research engineer at the University of Patras. And let me share my screen.
Yes, please.
Can you see the slides?
Not yet.
Not yet. Okay. Now maybe?
Now we can. Yes.
Yes, thank you.
The floor is yours.
Okay, so in the PeneloPe project, I'm work package 3 leader. This work package is related to the worker-centric tools. So I will introduce the wide range that we have. Of course, I will start with the PeneloPe project overview so that you can get an idea. Probably you already know due to the cluster what we're doing, but in any case, I will repeat. Then we will have some challenges that we face in large parts manufacturing. This is where PeneloPe focuses. And of course, some requirements that we needed to facilitate. And then we will start with the important and I guess more interesting part, the tools. So, what are the challenges in large parts manufacturing? We can say that, first of all, the components are complex. They require large sequences of tasks. So, they are also highly manual. We will elaborate more in the next slides why. They are time consuming. And this is also reflected to the design and construction preparation. We see a lot of deformations. The tolerances are not to the level that the end user wish. And so the European competitiveness in this sector is, of course, relying on the knowledge and skills of the workers. So we need to preserve the industry-specific knowledge of the workers. So PeneloPe has as an overarching objective the development of a closed-loop digital pipeline for flexible and modular manufacturing of large components. We are 30 partners that are working in this project, and the implementation of our tools will take place in 4 pilots coming from the oil and gas, shipbuilding, aeronautics, and bus and coach sectors. So you can see we have one-of-a-kind production and low volume. So we have 5 technical objectives. Of course, the closed-loop data-driven pipeline, the digital architecture that will allow for modular, reconfigurable, scalable, decoupled, and distributed production, zero defect manufacturing, which is also the reason that we are in this cluster. The worker-centric tools, which are expected to enforce workers by assisting them in their execution of the labor-intensive tasks. We will see the 4 axes where we support operators. And then, of course, we have the real scale demonstration. So let's focus now on the important part. Why we need these tools and what inspired us to work in these cases. So, as we saw, based on the pilots, but also on the market, large parts manufacturing is typically one of a kind or low volume. The processes tend to be complex. The parts are made of different sub-assemblies, so we have a lot of sub-steps in the processes. Parts come often in different tolerances. They deform during manipulation or handling. So we need a lot of craftsmanship on the shop floor. At the same time, the parts are heavy, maybe sometimes not even possible to manipulate by one person or two. So we have a lot of troubles. You can see in terms of human factors what this means. First of all, we have the potential of MSDs. There is physical stress. We have also a lot of high mental stress because the operators need to constantly make decisions. So how do I respond if the part is not in the wanted tolerance? What should I do if I see some deviation? How do I report some unforeseen event? How should the management be approached, etc.? And we can see some of the requirements that were shown to us, the developers, by the end users. So we need to prevent non-ergonomic postures, possibly by integrating robotic manipulators. We need to increase production responsiveness by allowing operators to directly provide feedback, because usually we have this feedback provided in daily meetings, and sometimes this introduces a lot of delays. We need to reduce the process time while improving accuracy and efficiency in process execution, reduce programming and setting times, and of course, improve training methods and enhance operator support on the shop floor. So here we can see indicatively some of the solutions. Of course, we have always human in the center, and we have a series of tools to support. So the programming can be supported, for instance, with AR tools. We can have human-robot collaboration to allocate difficult tasks that include discomfort to the robots. For large workspaces, we have cable robots, which are which allow to have more degrees of freedom for the manipulation of large parts compared to typical cranes. There is also zero programming solutions. And then AR operator support aside from human-robot interaction, just for the manual processes. And finally, offline training via VR tools. So let's see what happens for the intuitive human-robot interaction. We have indirect interaction. So here the human does not touch the robot. We have sensors that track what the human wants to do. For instance, create these waypoints, then show the planned path, and allow the robot to execute the path if we agree with it. And there is also this feature where we can directly drag the robot's end effector to the position that we want. And we have the benefit of seeing the robot's configuration while we're moving the robot. This is extremely valuable because sometimes we have singularities and the robot is moving a bit not as expected. So here with this feature, we make sure that the operator is always aware of what is going to happen. So we increase situation awareness, and this is planned for the commissioning of the robot. So not production stage, just setting up and defining the robot path. So for the robot programming, we have also the direct interaction, hand guiding techniques. Here humans can move the robot manually by applying forces on it. And we have again the benefit of easy trajectory programming. And here we have one more benefit. The robot can work as work-holding device to move heavy parts. Then a common element with the previous presenter, we have gestures. Here we detect them with an electromyography sensor. And these gestures allow to command the robot. We're talking about high-level commands like initiate task, return to home position, stop, continue, or pause task. And then we can move to the robots and what they can do. On the left, we can see a robot which can be either manipulated with a TP or work automatically. It's for very large parts, let's say. It can automate the handling of the parts and also assist the assembly. And on the right, we can see an example of a collaborative robot. In this case, it's also mobile. And it is integrated with a digital twin. For instance, here we can see when a sensor is on. Here we have some sensors to monitor the process, which is the gluing. But we have also integrated different sensors like safety scanners on the robot, safety radars on the structure, etc. Then another tool, it's also for programming, but this time we are talking more about software, not direct human-robot interaction. So we start with a human. They are performing the process as they would usually do. We record data. And then, as you can see, we can extract the robot path. And then using PathML, which is a form of automation ML, but also robot simulation, we can transform the path to whichever robot motion we need. For instance, you see here in the example, we have the tool moving, so the operator is moving the glue gun, but in the application, it's the robot that is moving the window. Of course, here we have reduction of time and effort to integrate the digital solution and more efficient transferring of monotonous tasks from workers to robots. So this tool is teaching by demonstration. It's called robot mimicking. And we continue with more zero programming. Here we have two different cases. It's milling and part inspection. So here from CAD and CAM data, including data from the actual environment, we adapt to deviations and disturbances of the environment, and we actually generate the path of the robot. Now we move to operator support and what we provide to the operators for manual processes. Here we have an inspection case. We have the overlay of NDT results, non-destructive testing. In this case, it's xerography. And there is also the marking of the area that needs to be checked. Apart from that, there are methods developed for repairing. In this case, it's resin infusion based. We have step-by-step instructions for the execution of the repairing as well. And you can see that we have tested exoskeletons as well to check if they are beneficial for the human. Of course, we have more paradigms. Here we have support for the measuring of parts. We have two cases, one in oil and gas and one in shipbuilding. So this allows to track physical objects and check if we have deviations. Also, it supports the design and generation of parts for the connection of tubes. One more AR-based tool, it's a projection tool that helps for calibration, that helps, for the tracing of cuts to be made on oil and gas tubes. And then we proceed with the offline training. Of course, here we have one big target, which is familiarizing with working next to the robots. Here it's important to familiarize with the notifications that we see in the systems, but also the behavior of the robot that usually changes. So, for instance, in speed and separation mode, the robot stops if you are very close to avoid collision, or it slows down depending on the distance of operator and the robot. And then it's also useful to know which tasks should be performed by the operators, which by the robot, how far we need to be at its place, etc. And then we have also training for hand guidance and other tasks. And then there is finally the VR-based human-centered task design. So while we're executing tasks in VR, we are also collecting data in order to decide if we need some redesign to improve efficiency, to improve postures, etc. You can find our solutions in this booklet. So you can expect around actually 11 modules for safe, modular, and flexible robotic technologies, 6 modules for intuitive human-robot collaborative solutions, 9 modules for AR and VR tools. And this is the work of 17 different partners. Here is where you can find us online. And thank you for your attention.
Thank you very much, Zoe, for sharing insights into the PeneloPe project. I have shared the link in the chat box to the booklet that Zoe was just presenting. Please remember that you can leave your questions for Zoe in the chat box. And now let's explore our final project of the day, that is I4Q. So please welcome Dr. Georgia Apostolou and Miguel Angel Mateo from the Center for Research and Technology, HELAS, Information Technologies Institute. Good
Hello.
morning, Georgia. Hello.
Good morning.
And Miguel Angel. Good morning. So you can share your screen. The floor is yours.
Can you see?
Yes, we can see it perfectly. Thank you.
Introduction and also for the invitation of I4Q project in this webinar. I'm Georgia Apostolou from CERT, and together with my colleague Miguel Angel from UPV, we will present you the I4Q project. Okay. I will start with a short intro. I know that most of us already know what it is about. Manufacturing companies are facing the challenge of redesigning and adjusting their systems to produce goods adapted to specific requirements and produced under the minimum required production rate, guaranteeing high quality and limiting the use of resources. I4Q project provides some solutions, a complete solution consisting of sustainable IoT-based reliable industrial data services, able to manage the huge amount of industrial data coming from cost-effective, smart and small-size interconnected factory devices for supporting manufacturing, online monitoring and control. At the moment, we are on the third year of the project, so normally the project would end at the end of December, but we got an extension of 5 months, and we will finish on May 2024. So we have already produced all our tools, the solutions that I will tell you more about that later on the next slide. And now we are on the stage that we are integrate our solutions in the factories, in the pilots. For this project, we have 6 pilots from different sectors. From white goods, we have the Whirlpool, for wood equipment, Bize, metal machining, Fidia, ceramics pressing, Riostone, plastic injection, Farplas, and metal equipment Factor. Today, we will give you an example of one of these pilots, and more specifically of Factor. We have developed 22 solutions in total. From these, 17 are software tools and 5 are guidelines. This toolset is able to assure data quality, traceability, and proper use to achieve manufacturing lines continuous process qualification, quality diagnosis, reconfiguration, and certification. Our solutions are divided into 3 groups. The first group is about manufacturing data quality. So there we have the following solutions. Quali Explorer for data quality factor knowledge. There the users can explore factors that affect the data quality characteristics such as accuracy, precision, timelines, credibility, and completeness. Trusted networks with wireless and wired industrial interfaces. Paying special attention to requirements there, such as predictability and determinism, high reliability and trustability, and low consumption, while reducing the installation cost of new wired infrastructure. Data repository, a flexible and scalable storage tool that allows customers to select a storage technology where to store their data. Blockchain and security handler that provide security mechanisms necessary in the industrial environment. The second group includes solutions for the manufacturing data analytics and quality assurance. There we have data integration transformation services, which is a tool that makes a pre-processing of data before using these into other solutions, not only from I4Q project, but also it can be combined with solutions that are already in the markets and are used by the factories. We have services for data analytics, analytic dashboard, digital twins, models distribution to the edge, big data and analytics suites, infrastructure monitoring, service for monitoring manufacturing lines, detecting failures and provide alerts, and edge workload placement and deployment, which is automatic smart delivery of AI workloads to the appropriate edge devices. The last one, group 3, rapid manufacturing line qualification and reconfiguration, includes the following solutions. Data-driven continuous process qualification. This tool applies statistical methods. Real-time process capability is calculated, which describes the scaled alignment to the desired quality range. Descriptive analytics tool. Rapid quality diagnosis, which is a microservice that supervises the quality conformity of products and provides visual assistance to the machine operators through quality metrics and graphical representations. And manufacturing line reconfiguration toolkit. All these solutions are combined in the pilots in order to solve specific problems. I will give the floor to my colleague Michel Angel to continue with an example of one of our pilots, which is Factor.
Yes, thank you, Georgia. Well, good morning. My name is Miguel Ángel Martillo, and I belong to the Product Management and Engineering Research Center at the UTPB in Valencia, Spain. And well, the idea is to make a presentation about the pilot Factor. Factor is a Spanish company specialized in the design and develop of the custom metal parts for many other companies. One of the most important challenges is the need to adapt quickly to the development of new parts. This is due to the fact that they don't develop a single product, but one that changes over the month. One of the most important value that their focus is in the quality of the final product and the reduction of the failures when he developed these new pieces, approaching a little bit with the paradigm of the zero defects manufacturing. If you pass to the next slide, Georgia. As you can see in this slide, we install different solutions from My4Q in this pilot with the intention to provide more quality improvement in the different development of the life cycle of the product. These solutions are distributed in 4 different servers and are directly to connect to the machine production. In this case, the machine is one machine that name is Nakamura 2. Thanks to this, we can obtain the data directly from the machines because the machine provided different internal sensors and act more precisely with the solutions in this machine. As you can see, there are several tools developed in this project implemented in this pilot. You continue with the next slide. Yes, for analyze the status of the development of the product and the implementation of the I4Q solutions, we have different KPIs to cover, from the quality of the control of the product to the automatic correction of the machine process. All these KPIs are reflected in the OEE. The main KPI for that Factor has to measure the quality of the production of the process. We can say that at the end, all this quality will be reflected in this value, in the OEE. In fact, if you continue with the next slide, Georgia. The OEE that has been improving through the project. In its initial phase, they have 62% of the initial value, and currently he go in the 71 level. Good idea of the objective of the factor is try to arrive to the 88% at the end of the project. At the end of the project at I4Q. However, these values are not entirely realistic in the last months because the company are including new machines with more sensors and change some aspects inside the line. And well, we can see that the last month we see that the KPS is down, but it's not a real value. In the middle, we see that the quality is increasing at the long of the time. These things we can see in other KPIs if you continue with the next slides, like the ability or the effectiveness. All these values provide the image that the introduction of these tools and the digitalization of the line produce a good overview about the state of the factory. If you pass to the next slide. Other measure is the quality radio, that we can see that all goes in a good way. And well, the last value, the number of the stops, well, is increased because we need to the factory need to do some stops to the new products and the new machines that it's included inside the factory. You continue with the next slide. With all of this, the idea is to share a demonstration of the videos. We decided to share the Trusted Network video because it's an interesting tool with a hardware component. And well, Georgia, you can share and
Yes, I will share another screen now for the video. Okay, we will show you the TN. Trusted networks.
Yes, we can see it. Yeah,
The
you can
following
even.
video shows.
Can you hear the sound?
Yeah.
Yes, we can.
Okay.
And you can.
You can even make it full screen.
Yeah.
Perfect.
I put it from the beginning.
The following video shows the software-defined wireless sensor network deployed in fact part of the Trusted Network solution of the I4.0 project. The solution is based on several wireless nodes that use a reliable and receiving communication protocol, powered by a centralized coordination of the SDN controller. Several wireless nodes has been deployed at factory, placing the gateway in the middle of the industrial cluster. The nodes support different industrial interfaces, such as 3210-volt and Modbus RTO. The use case tries to identify consumption patterns of a circular saw, predicting the blade wear. Using the web interface, an operator has access to all the labor information, such as the connecting nodes and also the network topology. The collected results allow us to identify the radio resource allocation and also the quality parameter of all the data flows. During the next steps, the information of the use case application will be processed.
And well, this is one of the solutions. As you can see in the video, this solution provides the possibility to deploy different hardware elements at the lawn of the factory. With these hardware elements, we can take specific data from different points, like the humidity, or if we put it inside the machine, the vibrations and this kind of thing that provided to the rest of the solutions or other solutions for other projects. There are other solutions that presented Georgia. If we wanted, we can share the video. That is, for example, the DAT is a solution that take the data directly from the machines and clean this data to send it to the rest of the solutions or to other solutions provided in the marketplace. Similar than the infrastructure monitoring. Infrastructure monitoring take data directly from the machines, and when appear an alarm, he send it this alarm to the operator and try to do the adjust that needed inside the machine, or something. Other solution that you can see here is the PQ. The PQ is a solution that provide overview of the state on live the qualification of the data that arrives. All these solutions are working in the idea to just with live data and provide as soon as possible a good result to help in the production line. And well, this is all for the factor case. You can pass to the next. Don't forget to follow in the network socials. As you know, we are at the end of the project and we are here to solve all the questions. Thank you all.
Thank you.
Thank you very much for your presentation. So I think we can all agree that we have had a great set of insights from our speakers. Thank you again for being with us today. So now for the last part of today's webinar, let's open the floor for the questions from our audience. So please feel free to submit your questions in the chat. I will just to break the ice, make a question while you write yours in the chat to our speakers. So my question to all of you, it's one of the things that we talk most when we talk about European projects is sustainability most of the times, but we also talk about replicability. So my question to you is if you can discuss with our audience what is the potential replicability of your methodologies and products, yeah, to other industrial sectors that are not the specifics to your projects. We can begin, for example, with our first speaker, Dr. Dimitriou.
Sure. Thank you, Ines. About replicability, at least for OPTIMAI and based off what I understood for the other projects, there is potential to replicate most of the solutions. But there is also a need to adjust to each factory. Because you need to study the use case. You need to understand, what kind of defects happen there, what are the breaking points of each process. That's the first step. Then you need to fine-tune your solutions that you have for defect detection, reconfiguration, whatever you need to do to adjust based on this use case. And then finally, you also need to integrate to talk to the actuators in the production line, to the robotic arms or the PLCs. So there is also this kind of integration effort that is needed. But the paradigms, the pipelines, the general concepts, I believe that they can be replicated, but there is effort involved in that.
Yes, we also talk, for example, in the case of PeneloPe, that is implemented in bus and coach, aeronautics, oil and gas. So would you like to comment on the replicability of the PeneloPe methodology?
On my part, it's very interesting, very impressive, because they cover a lot of many different domains. So I know that that's not easy, but maybe this Arculi can give you a better idea of that.
Yeah. So
You are muted. You are muted. Sorry.
Yeah.
Hi, thank you. So indeed, as you saw, there is a range of solutions. Some are hardware dependent, some others are not. So this also links with the replicability of methodologies and results. For instance, VR tools are much more easy to integrate. We just need data, geometric data, data about the task, and maybe some precedence constraints, and then it's easy to simulate tasks. Of course, there is a challenge of the number of steps that we can simulate each time. So this is what we worked on, how to make easier and feasible to simulate larger sequence of tasks. For AR tools, again, it's more challenging because we have also the actual world in the schema of the solution. But again, it's okay to proceed and adjust methodologies. We saw great work from TTPSC in the measuring of tubes, and they have actually transferred, I think, the solution from shipbuilding to the oil and gas. So there is already an in-project paradigm how to move from sector to sector. Again, I think the matter is how to calibrate the solution with the environment, how to achieve tolerances, because the overlay needs to be accurately projected on the actual part. But again, it's a matter of data. We have some integration in the basin code sector with other tools. For instance, VR, AR, and the task planning for repairing, they have to be integrated. So we're working on a solution where the partner IPC who have developed the repairing methodology indicate the steps for its type of defect. And then these steps through the Skillworks platform of TTPSC, and we're also testing the digital thread of PeneloPe, will be shared for AR and VR. So what differs is the instructions to the operators, and then how to calibrate with the environment. When we have robots in place, we are currently working with ROS. So from the moment a robot has a ROS driver, we can replicate the methodology. So it's AR and robots. For the hand guiding, I'm not really sure because it's the development of another partner. I think the methodology remains, but we have to respect the constraint of its robot, the constraints of its robot. We have worked with ABB and KUKA robots inside the project, so we already worked on the replicability. The cable robot is somehow challenging to transfer from case to case because it requires a lot of work in the design and manufacturing of the robot, but it's doable. Again, we have two cases, one shipbuilding and one basin coach. Collaborative robots. It depends. Do we need a manipulation task? It's just inspection. For the inspection part, it's easy. We have done NDT inspection and the vision laser-based inspection with the same robot. It was easy. It took 1 month. So it pretty much it depends on the requirements and what we want to achieve, how different it is from the baseline implementation.
Indeed, indeed. Thank you, Zoe. Some inputs from Georgia and Miguel Angel regarding replicability?
Yes, sure. In our case, I think that the tools are not so complex as in Penelope. I see the differences. So in I4Q, the aim is to use these tools also in other factories with other kind of data, of course, with some adjustments. I mean that depending on the case and the data that we want to use in order to have the results that we need, there might be necessary to do some adjustments, updates on each one of the tools. But I think that easily could be implemented in other cases. Maybe with some guidelines, of course, always this is very useful, but not with great adaptations and major changes.
That's yeah, that's great. We have a question in the chat that I think it's a very interesting one. It's a question to everyone. So the question reads as follows. We are interested in hearing more about the human feedback aspects in the project. How would you describe the feedback on your human-centric tools received from users so far? And if has the feedback been mainly positive or negative, and has it resulted in significant changes to the tool's functionalities or interfaces? We can begin with Dr. Dimitriou.
Yes. So on our part, the feedback has been mostly positive, and as you saw in my presentation, the feedback is not only just evaluation. We basically want the workers to use in longer term our tools so that we can also gain from their expertise and knowledge with this active learning and decision support annotation based feedback. But mostly the answer is that the feedback has been positive. Of course, there have been concerns with some of the workers, because some of them might feel threatened because automation. Okay, maybe I will lose my job in the long term. So there are this kind of concerns. We need to be sincere about that, because ideally, if automation progresses, factories won't need any workers at all in the end. But our answer to that as a project, and me personally as a scientist, is that you need to help based on the background of each worker, to help them evolve, and uptrain. So you need also to have not only take feedback from the workers, but also you need to train them, to upskill them, to show them the way that through using this technology, you can also learn, you can evolve in your profession as well. So that's it from my side.
Yeah, thank you. Thank you. Zoe, in this case, have you have any feedback from the implementation of these tools?
Again, I will reply in levels. VR solutions, they are quite appealing, I can say. They are well appreciated. And okay, the scope is to gamify how to learn the process. So yes, it was quite positive, the feedback. About the projection tool, we know there were several iterations. So we're working with the end users to improve the tool. I think it's well appreciated by humans. What has been worked on is the accuracy. AR, it's for the tubes, it's also positively received. As for the robots, we need yet to test it with operators because in the cases where we have them, the robots are not yet at the end user's place. So in order to get the operators' feedback, we need to wait a bit more. From past experience, we know that it's well received. Of course, there are some things to work on. For instance, the autonomy of the device, but this is not our job. Unfortunately, we are limited to the application side. And then for the robots, okay, it depends. Sometimes it's positive, some other times it might be intimidating. It's a matter of how we design the application. Is it that we're taking the job from workers? Is it that we're combining what they're doing together? We are taking discomfortable tasks that no one wants to do. It depends. It depends. For instance, gluing, it smells awfully, so people are quite happy not to do it.
That's very good. Thank you, Zoe. We have also Georgia and Miguel Angel. Would you like to comment on this?
Yes, well, hello, that's my turn now. So far, well, we have tested it with the engineers and the pilot representatives because we want that the solutions work correctly inside the factory because effectively in the final product. But directly with the plant operators, we don't have interactly in this moment. In fact, the idea is in the next 5 months, in the extension of this project, try to have a feedback directly from all the stakeholders that interact with the solutions. From the business level to the operator at the end that it will be used at the solution.
Mhm. Thank you very much, Miguel Angel. Yeah.
Mhm.
I have here in the chat a question for Dr. Nicolos. So the question reads as follows. OPTIMAI explores the rapid reconfiguration of production equipment. How does this contribute to a worker-centric approach, and what challenges may arise in ensuring the seamless transition for workers?
Okay, well, indeed, an interesting question. So, uh, for OPTIMAI, configuration can be it's not it can be either autonomous, meaning that you have AI that does the configuration to adjust the process and optimize the process, or configuration might mean that it is done by the worker. Okay, and I'm talking about online reconfiguration, not about planning your production in using a digital twin and then applying this reconfiguration to the software. I mean, it's online, so you can go next to your machine and do some gestures to reconfigure some parameters, or you have on the edge an AI module with reinforcement learning or whatever that monitors the process and does micro adjustments to configure and optimize the whole process. Now, about how this contributes to a worker-centric approach. There are two ways here again to do it. As you saw with augmented reality part and gesture recognitions, you can have the worker basically perform the configuration task. So he can, with the gesture, the vocabulary that we have developed of gestures, each different gesture signals a different reconfiguration action, like things like, slow down the conveyor belt or stop this machine or tune up this parameter. This kind of things you can do with gestures and reconfigure your production. The other part of reconfiguration, which is autonomous, it does not involve the worker at first glance, but it does involve him when he corrects actions, configuration actions through the DSS, through the decision support system. So when an action, a configuration task is automatically done and it is stored in the blockchain of OPTIMAI, because that's the way it right now works. The worker can go in the DSS and say, no, you did this wrong, and through this feedback, the AI reinforcement learning agent, whatever kind of AI model you have, can learn from the human, from this experience, and don't repeat the same mistake again in the future. Now, about the challenges that arise in ensuring a seamless transition for workers. Yes, there are a lot of challenges, that not only technological ones, because the technology might be there, but the biggest challenge in my part is that you need to change the mentality of the worker. You need to explain to him what this thing does. You don't necessarily, of course, you don't present him with the mathematics or equations or no, but you have to give him a clear picture of what this technology that you are proposing or that you are integrating does. Okay, explain to him clearly what his expected role is in this technology, whether how he's expected to use it or how he's expected to help it. And also, again, repeating my previous answer, you need to help him understand that this is an upskilling task for him as well. So he will learn new things, and he will develop new expertise through his involvement with these technologies. So that's the biggest challenge on my view.
Yeah, thank you very much. We are running out of time, but before we close the webinar, I would like to just pose a question to all of our speakers. That is, there is always this fear, right, that the workforce or the workers will not be as needed in this upcoming Industry 4.0. Yeah. So my question to you is like how you envision, how your projects envision the support to this workforce transition towards Industry 4.0, how you are preparing, for example, in the case of Penelope, there is an expression of interest coming with trainings. Is there something like that? Skills uptake that you are planning on? Perhaps we can open this question with Zoe. If Zoe is
Hi,
available.
sorry,
Yeah.
I was a bit confused because you provided the answer. We do plan to have some trainings. So yes, first of all, as you saw in all of the solutions, we keep human in the loop. So okay, let's talk about the robots because for AR and VR it's quite obvious. So what we want is, what we envision to do is to get monotonous jobs that require also maybe high accuracy to the robots, whereas we keep more interesting creative tasks that require maybe flexibility, decision making, or improvising for humans. This is the target. So do end user like it? We need to work a bit on the efficiency that we achieve in the human-robot collaborative scheme, but for sure there is potential. And yes, also we have these trainings that you said. So we hope to make people more keen with programming these AR/VR applications, using them. There is also training for the human-robot collaboration, robot programming. There is a wide range of trainings.
Thank you, Zoe. Dr. Dimitriou, do you have some initiative like that in OPTIMAI?
Well, yes, in OPTIMAI we have a task that is dedicated to training and upskilling of workers. So yes, we are doing that. Basically the goal for these training activities is to enhance and highlight the new role of the worker in Industry 4.0. Okay? Because it eventually comes to that. It's not that you don't need humans at all. Everything is automated. It's that humans now should do other different kinds of tasks. So that is the focus in the training. Basically, we want to show them, how things are changing based on the technology that we're developing and technology in Industry 4.0 in general, and then explain to them what is their role in this transition and where they are still needed.
Yeah, thank you. So the question same for Dr. Apostolou and Miguel Angel.
We also include training in our tasks. It is already started with the people that use these solutions inside the pilot. But of course, through this training, we are trying to improve our tools. So depending on the feedback that we receive, we are trying to make some adjustments and make it easier for the persons that use it to use it and understand the results, and also make it more friendly, let's say, to people that have no technical knowledge on the specific tools. There is already interest for some of the tools, also from externals, and I think that they could provide help to employers with problems such as the quality of the final product or the machine. So I find it useful, and I think that in the next years tools like that will be used broadly in the manufacturers. But if you want also direct feedback, I think that some colleagues of us from Factor, Pablo and Alfredo, are here. So maybe they can comment on that also, like what they believe about the tools that they use now in their factory.
Yeah, perhaps. I mean, we are running out of time, but if they
Okay.
want to have like a 1 minute comment on that.
Yeah, if you want, we can just very, very quickly dent into that, in the sense we were exactly talking about that. I mean, we consider, first of all, two very quick ideas, Ines. It is extremely useful because we are connecting our indicators, our key indicators, the OEE, with a layer of data analytics that without that we are not able to improve our production targets in terms of quality, availability, and performance. On the other hand, we must not forget that we are talking about projects which are TRL 7. We need only to think about something that is pretty simple, but is not in our domain of expertise, is ergonomy. Any new tool, even with the best of the ergonomy, has an obstacle is a new thing in the shop floor. If we add the right ergonomy, or we integrate this tool properly into the ergonomy of the existing tools, it can be very useful. It can be very, very useful because it's very connected with our productivity and efficiency targets.
Yeah, that's a wonderful insight. Thank you very much. Thank you, Alfredo.
You're welcome.
So as I said, we run out of time. So from my side, I just would like to give a big thank you to our speakers, a big thank you to our audience, and also a big thank you to the DVA for hosting us today. I hope you found this webinar as interesting and refreshing and informative as I did. So with that said, we welcome you to visit the websites of OPTIMAI, I4Q, and PeneloPe, and also the 4CDM cluster. So thank you very much for being with us today, and see you next time. Thank you.
Thank you.
Thank
Thank
you.
you, everyone.
you.
Thank you, Ines.
Ines.
Thank you. Bye bye.
Thank you.
Thank
Bye-bye.
you.
Ciao,
Bye.
ciao.